Hello friends, welcome to the channel. Now in this topic I will cover the chapter light. So what will you learn in this video? So you will learn what is light, use of light in our daily life, reflection of light, law of reflection, Newton's disk, spectrum of light and prism, how rainbows are formed, plane mirror, spherical mirror, convex mirror, difference between concave and convex mirrors, lens, concave lens, convex lens, difference between concave and convex lens, difference between mirror and lens. And in last, you will also learn about some important terms. So let's move to the topic. So what is light? Light is a form of energy that our eyes can detect. Light enables us to view our surroundings. Light travels in a straight line. So here are some of the uses of light in our daily life. Vision and sight, drawing and evaporation, sanitation of earth, temperature regulations, health care, operating solar cookers, body growth and sleep, photosynthesis. So let's move to reflection of light. When a ray of light strikes a smooth, polished surface and the light bounces back, it is called a reflection of light. In this image, you can see the light strikes a smooth and polished surface, which is a mirror over here, and then the light bounces back. So this is process of reflection of light. There are three types of reflection of light: regular reflection, diffuse reflection, and multiple reflection. Regular reflection. Specular reflection refers to a clean and sharp reflection like the one you get in a mirror. A mirror is made up of glass coated with a uniform layer of a highly reflective material such as powder. This reflective surface reflects almost all the light incident on it uniformly. There is not much variation in the angles of reflection between the various points. This means that the haziness and the blurring are almost entirely eliminated. Diffuse reflection. Reflective surfaces, other than the mirrors in general, have a very rough finish. These may be due to wear and tear, such as scratches and dents or dirt on the surface. Sometimes even the material of which the surface is made of matters. All this leads to a loss of both the brightness and the quality of the reflection. In the case of such rough surfaces, the angle of refraction when compared between points is completely haphazard. For rough surfaces, the rays incident at slightly different point on the surface is reflected in completely different directions. This type of reflection is called diffuse reflection and is what enables us to see non-shiny objects. Multiple reflection. A single image is formed when an object is played in front of a mirror. What happens if we use two mirrors? Since reflective surfaces such as mirrors are very good at preserving the intensity of light in a reflection, a single light source can be reflected multiple times. These multiple reflections are possible until the intensity of the light becomes low to the point that we cannot see. This means that we can have almost infinite multiple reflections. We can also see an image in every individual reflection. This means that each image is the result of an image or an image of an image. The number of images we see depends on the angles between the two mirrors. We see that as we go on decreasing the angle between the mirrors, the number of images increases. And when angle becomes zero, this is when the angles become parallel, the number of images becomes infinite. This effect can be easily observed when your barber uses another smaller mirror to show you the back of your head. When this happens, not only do you see the back of your head, but you also see innumerable images of yourself. Let's move to law of reflection. So, law of reflection determines the reflection of incident ray on reflecting surfaces like mirror, smooth metal surface, and clear water. Let's consider a plane mirror as shown in the figure above. The law of reflection states that the angle of incidence is equal to the angle of reflection. Here, the incident ray is the ray or is the light which strikes on the mirror, and the reflected ray is the reflected light which bounces back from the mirror. So, the angle from the incident ray and angle from by the reflected ray are equal. Now, here normal means perpendicular. The incident ray, the reflected ray, and the normal ray all lie in the same plane. Newton's disk. This is a very important term or a experiment done. The Newton disk, also known as the disappearing color disk, is a well-known physics experiment with a rotating disk with segments in different color. Usually Newton's primary color, violet, indigo, blue, green, yellow, orange or pure, appearing as white or off-white or gray when it spins very fast. It proves that the light contains 7 different colors: violet, indigo, blue, green, yellow, orange or vigor in short. So let's move to spectrum of light and prism. So first of all, before telling about spectrum of light, let me tell you about prism. So prism is a transparent body that is bounded in part by two non-parallel plane faces and is used to dispense a beam of light. In the 17th century, the word spectrum was introduced by Isaac Newton, referring to the range of colors observed when white light was dispersed through a prism. Soon the term referred to a plot of light intensity or power as a function of frequency or wavelength, also known as spectral density plot. The term spectrum was expanded to apply to other waves such as sound waves that could also be measured as a function of frequency spectrum and power spectrum of a signal. The term now applies to any signal that can be measured or decomposed along a continuous variable such as energy in electron spectroscopy or mass to charge ratio in mass spectrometry. Spectrum is also used to refer to a graphical representation of the signal as a function of dependent variable. Now, you would have been wondering, how are rainbows formed? So, rainbows are formed due to a phenomenon of refraction and dispersion of light. After the rain, when the sun is low in the sky, the rainbow is seen as a large arc with many colors. When observed carefully, there are 7 colors in a rainbow. These are red, orange, yellow, green, blue, indigo, and violet. Rainbows are formed due to phenomenon of refraction and dispersion of light, as we know. When white light passes through a medium of different optical density, it changes its direction of propagation slightly. This causes the light ray to change its velocity in different media, leading to a phenomenon called refraction. White light consists of 7 different colors that have 7 ranges of different wavelengths, representing each color. When white light experiences refraction, it splits into 7 different colors. So here, the water droplets are acting as a prism and the sun as a source of light. So now let's move to plane mirror. What are the characteristics and properties of a plane mirror? So the characteristics of a plane mirror are: image is laterally inverted, image is direct and virtual, size of image is equal to size of the object, distance of image is equal to distance from the object. So now you would be thinking, what is lateral inversion? So when an image is formed by the mirror in such a way that the left side of the image is the object's right side and the vice versa, This is known as lateral inversion. So what are spherical mirror? Spherical mirror is a mirror that has the shape of a piece cut out of a spherical surface. There are two types of spherical mirror, concave mirror and convex mirror. Concave mirror. So we know that a cutout of a reflected sphere is a spherical mirror. If the reflective surface is on the side curved inwards, it is a concave mirror. Here you can see the reflected surface is facing inward. So now what is the nature of image formed by concave mirror? When an object is close to the mirror, the image formed is real, inverted and enlarged. Uses of concave mirror. Used to magnify object, used by dentists to obtain magnified image of teeth, used in solar heaters, flashlight, headlights of cars, etc. Now let's move to convex mirror. Similarly, if the reflected surface is curved outwards, it is a convex mirror. Convex mirrors are used extensively as a part of car mirrors. Depending on the focal length, the reflected image is reduced in size, but the field of view is more. So the nature of image formed is virtual, erect and diffused. Wait, do you know what is virtual or real image? So you can see an image formed on a screen is a real image. Such an image is called the real image. The image which cannot be formed on a screen is a virtual image. So let's move on. Use of convex mirror is as a reflector at sharp turns, in parking lots, in bikes or cars. So now what is the difference between concave and convex mirror? So the concave mirror, it is thinner in the middle and thicker at the edges, whereas convex mirror, it is thicker in the middle and thinner at the edges. Concave mirror is also known as diverging mirror and convex mirror is also known as converging mirror. So now let's move to lenses. So what are lenses? Lenses. It is a piece of transparent material bounded by curved surface. According to the shape and purpose of the lens, they are classified into two types, concave lens and convex lens. A concave lens is a type of lens with at least one side curved inwards. A concave lens with both sides curved inwards is known as biconcave lens. Concave lenses are diverging lenses. That is, they spread out light rays that have been refracted through them. They have the ability to diverge a parallel beam of light. For a concave lens, the edges are wider than the center or the center is thicker than the edges. Concave lenses are used in spectacles in order to overcome myopia or short-sightedness. The image formed by a concave lens is virtual, erect and diminished. Convex lens. Convex lens is a lens with an outward curve. Like the concave lens, the thickness at the center of the convex lens is more than the thickness at the edges of the lens. Convex lenses are converging lenses. Convex lenses is used as a camera lens. It is also used in microscopes. And guess what? Human eye is a convex lens too. Image form is greater than the object. Now let's know the difference between concave and convex lens. So, concave lens. Concave lens is thinner in the middle and thicker at the edges, whereas in convex lens, a convex lens is thicker in the middle and thinner at the edges. Concave lens are known as diverging lens, whereas convex lens is known as converging lens. Concave lens. The image form is an upright virtual and smaller size than the object. The position of the image formed is in the between the lens and the object regardless of the object's position. Whereas in convex lens, the image form is inverted, real, and smaller than the object when the object is placed at focus. The image formed is the inverted, real, and the same size as the object when the object is placed at 2f. The image formed is inverted, real, and larger than the object when the object is placed between 2f and f. 2f here means second focus. Image is formed at infinity when the object is placed at the focus. The image formed is upright, virtual, and larger than the object when the object is placed on the same side of the lens. So you should know the difference between a mirror and the lenses. So we can say that mirror implies a glass surface with a silvery backing that produces image through reflection, whereas the lenses mirror implies a glass surface with a silvery backing that produces image through reflection. Lenses are also transparent. So here are some of the important terms. Center of curvature. The point in the center of the mirror passes through the curve of the mirror and has the same tangent and curvature at the point. Radius of curvature. It is the linear distance between the pole and the center of curvature. Principal axis. The imaginary line passes through the optical center and the center of curvature of any lens or of a spherical mirror. Pole. The midpoint of the spherical mirror. Apparator. An apparator of an image or a mirror or a lens is a point from which the reflection of light actually happens. It also gives the size of the mirror. Principal focus. Principal focus can also be called focal point. It is the only axis of a mirror or lens wherein rays of light parallel to the axis converge or appear to converge after reflection or refraction. Focus. It is any given point where light rays parallel to the principal axis will converge after getting reflected from the mirror. Thank you for watching this video. I hope that you understood the concept well.